Hello. Okay. Hello and welcome to the PQUIP meeting. So just to remind you, if you haven't been to any other IETF meeting, we have the note well. In case of any kind of conduct that you think constitutes harassment or you just have some concerns, there are different procedures that we have at the IETF, and we're always happy to be reached at the Ombuds team as well if you're interested. But just to remind you, here is the note well. Also note really well that these IETF meetings is usually also recorded, and by participating in them, you are allowing us to record you. All of the links of the presentations will be eventually findable in YouTube. Also, some working groups meeting tips. Please remember that if you want to say something about any presentation or if you have any questions, please add yourself to the queue via the data tracker, which provides a really nice mechanism. So please always join the mic queue. And please also keep the audio and video off if you're not on site. If you're using offline, please keep it off unless you obviously go to the mic. Just some agenda overview. We have some older document statutes. We're going to be talking about some newer documents as well. Some things that have been happening in the IETF this week, especially there's some meetings on PQD and ESEC that seem really interesting. Some potential of new working group items that you will see, and the usual presentation on PQC at the IETF. And please find the full agenda in the URL in this slide. Okay, you want to do, Karen?
Yeah. So for those of you who've been coming a bunch, you know that we have 3 documents that are quite mature. In fact, the first one is fully mature. That is, we have our first RFC on hybrid schemes. So that was published last month. Hybrid signature spectrums, we'll have a little presentation in a bit, but it has finished IESG review. There is one AD who has a discuss on it who just has been busy. It's not like in some of them that we've been going back and forth on the discuss. It's just he's been busy. We should hear about that, but again, we have a little presentation on that in a bit. And then the giant post-quantum cryptography for engineers document, which did very well in my view during IETF last call. It was fairly constructive. People were appreciative that it exists. It's still in IESG evaluation. It's on a telechat for like 2 weeks from now, 3 weeks from now. We need to give the area directors a little bit of time after an IETF meeting to breathe. But so that one, for those of you who aren't that familiar with IETF process, all of the ADs get to cast a ballot about whether they have an opinion, no opinion, or they want to block it. We haven't seen any votes yet, but you don't normally see them until like the week before the telechat, just because they're just in time driven like many of us are in our jobs. So we will see those on the mailing list when they start coming in. And then there will be the telechat on the 7th, and then we'll know more at that point. So that's our current documents. Next. So a couple of things that are happening this week. There was sorry about that URL. That's like totally wrong. Ignore that. There was, as always at the hackathon, a whole bunch of people working on PQC and certificates. Do we have a presenter for that today? Do you want to come up and do that now? So that's our first set of slides. Yeah. But ignore the URL. I do have. Yes, and we.
Yes, so this is John Gray. I'll give you an update on the hackathon in a second when the slides come up.
Hold on. Yep.
Yeah, so you can all see the slides there. So yes, this is IETF 123. We're here in Spain. We all know that. So this project, you probably know, we've been doing it for a couple of years now. essentially we got together and said this would be great if we could test all these new PQ algorithms coming. Let's do this. It'll be really fun. So we did just start doing that, having interoperability tests with different implementations. I think we're up to like 12 to 15 different implementations now, or different providers. That's what we call them. So that's great. It helps us gain experience using these PQ algorithms, but also provides feedback to the standards group. And you can see there's a whole bunch of drafts there. Most of them are in the LAMPS working group. You notice some of them have RFCs beside their names now. When we first started, none of these had RFCs in their names. So one by one, these are becoming RFCs. So we're testing these even before and even afterwards. So that's great. So what got done this time? So as always, we have a repository. It's in GitHub. So if you go to the IETF GitHub page, IETF Hackathon GitHub, there's that PQC certificates. You look there. So this time we did some maintenance updates to the OID list because new OIDs are, IETF, sorry, for instance, the composites, we had some new OIDs that happened, so that needed to get updated. There were some new people joined, which is great, and then we needed some clarification on the wording of how the artifacts worked. So we defined specific formats. So that needed a little bit of clarification. We did remove the open quantum safe library as an automated verifier. The reason for that, one, it's mainly meant to be a research library, and some of the algorithms like SLHDSA, for instance, hadn't caught up to the standard yet, so it was causing a number of failures in our matrix results, which I'll show you in a few minutes. We had lots of discussion on the composite key formats, which you're going to hear about probably from Mike later during this session. Yeah. So I'll go to the next slide. Yeah, so what else got done? There was a lot of people, like this time we had about 16 to 20 participants between on-site and remote. So for instance, a couple of days ago, 7sense AI, they added some new artifacts. So a lot of people added updated artifacts because there's some of these new algorithms from the composites, things like that. So just, I have the people's names beside there if I don't mention all your names, but I thank you to all of you for participating. It's great to have people. So another one, Alex Slaslaski from Safe Logic joined for the first time. He added artifacts as well. Cryptophore, JP Fazane, he had a bunch of his people with him as well. Working remotely, they added new artifacts to the repository. CHT added artifacts. So lots of new artifacts being added, but also testing with each other as well. So one of the things that I'll show you in a second is if you generate these artifacts, you can upload them and then there'll be automation that happens, but also you can also download anyone else that has submitted artifacts and test with those. So these people have been doing that, testing everyone else's artifacts. So that's great. Yeah, so just thank you again to everybody for this. We also had the first composite chem reference implementation artifact files added. That's thanks to Stefan Yakimovich. Sorry if I get your names wrong. So just a lot of collaboration going on. So what we learned a lot of things, even more than this list, and we continue to learn things. So again, a lot of this discussion on this key formats. So people were implementing the composite key formats from the version 7 documents. People said, they found it straightforward. It wasn't, in fact, people had said that previous versions maybe use things like ASN1, using what's there now today without that was very straightforward. It works. One of the people, I think it was actually Dan Van Geest, he implemented an OpenSSL. He said it wasn't difficult. So that's good to see. One thing that did come up is many crypto libraries don't yet support the seed format. We think that's probably going to improve as time goes on, but that's just the status of things.
Before you go on that,
Yeah.
can you say a bit more about the seed format
Okay, yeah.
and is that formats plural?
Yeah, sorry. Yeah, I guess I just assume all of you know about this because of all the discussion. So the seed format for MLDSA or MLChem, so it's either 32 bytes or 64 bytes, depending which algorithm, versus the expanded format. So that's I think in MLDSA it's like 12 something to 2400. So the seed format's basically it's like a random number where you start, but you can that's the most smallest compact format of the key that can be used. And then it can be expanded and used as part of the algorithms. Is that enough information? I think. Yeah, it's
I
just,
think so, but since you were saying that some of them are not supporting,
oh, yeah,
they're
okay.
supporting something, but not the.
Yeah, sorry, yeah, sorry. In terms of, so if they don't support the seed format, they're going to export what's called the expanded format, so the alternate format. And I guess the reason for that is because in the NIST documents, like the seed format is there, but it wasn't as clear, or at least that's my understanding. But the, the expanded format from doing the key generation routines is there. So a lot of the initial, like Open Quantum Safe and other cryptographic libraries that first added these things, that's where they started with the expanded format. So that's why some of these libraries haven't caught up to the latest where the seed format is supported now. And so I'll show you a couple example of the results, so other things that we're still learning. So this is an example of the compatibility matrix, so the manual testing. So again, this is, you can see on the top column there, it's kind of small. There's about 9 or maybe 10 or 11. So like Bouncy Castle is the one on the top left. On the top right is 7th Sense AI. So those are different, what we call providers, people that have submitted artifacts. So in the manual test, that means like Bouncy Castle, that team, or who was working on that, usually it's David Hook. He took what he did, and then he would download like Carl Redhound, CHT, each one of those providers, and then he manually runs his stuff against each one of them, and then uploads. We have a format file, a CSV format file. And then you run them together and you get the results, and then you post it back, and this basically results table is completed. And you can see all this on our GitHub as well. So if you go there, it explains how this works. And then if you see on the left-hand side there, like these are all different algorithm combinations. This isn't even showing the whole list, right? So there's the Falcon, which is not standard yet. I don't think there's even an IPD yet, but that's supposed to be coming soon. But the MLDSAs are there, SLH DSA. Didn't have room to show them all. But if you actually click on any one of those, so each one of those, you can actually see a more granular output of the latest results. So in this case, you see, like when you see green check marks, that's great, right? Because green check marks means things are good. But you see on the right-hand side there, there's like a little like Entrust has an X. I work at Entrust. That's because I did not have time to update my artifacts in the last round. So and what happened is the certificates I had put in the artifact format, they had actually expired. So lesson learned, I should probably use long lifetime certificates if I'm going to use them for this testing. So little things like that come up interesting. I think the CryptoNext was the other one, and I think Dan had the same issue, and I think he's already fixed it by now. So these slides are from 2 days ago. So if you go there now, there's probably going to be even a little bit different results, right? So this is a dynamic thing that as people keep updating it, these results change. This is the first time we actually have MLChem results. Well, not the first time, sorry. This is the example of MLChem. And you can see there's actually pretty good support. I didn't mention the 3 out of 3 and 4 out of 4. Those little things means that specific provider tested with 4 other providers, right? So you can actually see if there's about 5 of them. So sometimes, depending on when people test each other's stuff, there might be not everything was there. So some of the older ones, like on the 7th Sense AI, they didn't update artifacts this time, so you only see like 1 out of 1. So I think the last hackathon or a few hackathons ago, they added artifacts. They were the first ones. They only tested with themselves, right? So this is, again, these results change as people add things. So the other cool thing, okay, sorry, I'm just showing, this is showing composite chem as well. So we actually have the first actual interop testing between composite chem implementation. So we have the new composite chem reference implementation, but also CryptoNext has also implemented those as well, right? So this was great to see. So obviously we'd like more people to implement that so we could have more testing, but that's showing that it's working, it's great. And then we have automated test results. So these ones, again, are a little bit different. So now we have on this results slides, which actually changed since this morning when I talked to Dan. I'll give you an update in that in a second. So as of when I did these slides 2 days ago, we had 3 automated verifiers. So Bouncy Castle, the one on the left there, the composite signatures reference implementation, and 7th Sense AI. So those, we use GitHub Actions. So when you submit your artifacts to this, those GitHub Action automatically runs and will run your stuff against Bouncy Castle, 7th Sense AI, and then now the composite signatures reference implementation. I think if you look there now, there's actually going to be 4 of them because Dan Van Gies just told me this morning he just did with OpenSSL, he added an automated verifier as well. So now with basically one upload, you can within 2 minutes, this table will be automatically populated and you can see if how your results are. The other thing we're looking for, someone had started, Joseph Lukefar started last summer, I believe. He started doing an automated one using the NIST ACVP tests. So we're still hoping to complete that one. Some of the NIST guys I've talked to, I think maybe we'll get some help from them and that can be completed, which would be great. So that would be another automated verifier that we could add that would then obviously give, people could put their artifacts up here and then very quickly know whether that ACVP implementation, if they actually are good with that. So I think that's, yeah. And also this is the composite signatures one. So something else we learned, again, I mentioned we have feedback to the drafts. So you see there's it doesn't look, you don't see green there, right? So there's a composite signatures reference implementation. That's pretty new since the last draft updates, but it's not quite working with the other one. So we have found there's a couple of things that need to be fixed there. So again, this is a good outcome on the project, right? It shows that we need a little bit more work. And this is what we're trying to do, is do that interop testing so that it can help us get things correct. So I think with that, yeah, with the summary, we've had about 50 people be part of this project. A bunch of new timers this time. Alex, I mentioned Stefan, Andrew, Burry, and Zane. They were first timers this time. This is kind of just a snapshot of our table. So we have remote participation. So this was table G at the Gather Town. And we do have monthly meetings. So our next one's going to be Tuesday, September 9th. So this project isn't just a one-time like hackathon thing. It continues. We keep adding, new algorithms. I'm sure people are going to want to come and test like HQC or, Mayo or those new algorithms that are coming down the pipeline. When we get an IPD of Falcon, right, that's going to be something we want to test as well. So with that, yeah, I'd say, come join us. And we have lots of fun. We had our team hackathon dinner last night. That's lots of fun. So. Any questions? Okay.
So we jumped around incorrectly on the slides. I'm going to do a quick announcement for those of you who are interested in DNSSEC. There's a post-quantum DNSSEC side meeting. I have it listed in the agenda. That's Thursday. It got moved, so it's now Thursday at 8:30. 8:30 to 9:30 in the small group meeting. You've got ones for, you were saying, for the ANRW?
Yeah, so we're here. Yes. So if you're interested in post-quantum in DNSSEC, you can attend the meeting also just right now, but also as part of the how is it? The NRRW workshop. There's also a presentation on post-quantum DNSSEC and how Falcon specifically works on it. So if you're interested again in how post-quantum signatures work on DNSSEC, please attend any of those two meetings.
Right. Okay. So let's jump back now to our current document statuses. We've got 2 documents now, hash-based signatures. No, next one. Or did I? What's the next slide? Wait, go back one. Huh, okay. I didn't do a slide on this. So we have, which is sort of odd because these are our 2 current documents. If you look in the agenda, you will see that we have hash-based signatures, state and backup management, and adapting constrained devices for PQC. We've got presentations on each of those. So Tom, are you here?
Yep.
Yep. So you will get. That one. There we go. Would you like to do your own clicking?
I would much prefer to do my own clicking. Good morning. Good to see that the crowd for PQUIP is getting one of the big rooms now. Stateful hash-based signatures, how to handle them. This has now been graduated from a draft Wiggers to a draft IETF PQUIP, so we're quite happy with that. And today I'm going to basically tell you a little bit about what happened since the last time that I spoke, And then I want to basically have a discussion on how we proceed with this document to get it into, well, A, the best shape that it can be, so that it's the most useful for everyone, and B, so that we can establish the direction and the way to sort of finish this up. Where's the end goal, where we're going to call it, and I want to really open up for any feedback there. I would much rather run out of time than reach the end of these slides. They're ordered in sort of importance, so if we don't get to the end, we don't talk about slightly less important stuff. That's fine. And maybe to remind everyone what this was about again, stateful hash-based signature schemes are post-quantum type of signature scheme, but basically it's a list of one-time signatures that you can use. And if you happen to reuse something, then you lose all security immediately. Very bad. This makes things tricky because suddenly you have a private key that you can no longer just make a copy of and store on some hard drive in a safe somewhere, because that copy will not be updated as you go along with where you are in sort of this consumption of this thing, because suddenly your private key is sort of a consumable good in a way, which is very weird and new to a lot of people. So in this document, we're trying to sort of capture how to handle this, how to turn this into something that you can run in production in a safe way. So since the last IETF, we adopted this draft as a working group. So now it's no longer just my responsibility, but our responsibility. We fixed it, and unfortunately, I was also very busy, and my co-authors were busy, so we didn't do a lot in sort of adding new text or whatever. We fixed the typo. There were a few discussion points on the list that we converted to GitHub issues that we would like to visit a bit more attentively and address. But also, if anyone has opinions about any of that, then please also find them there. So that brings me to what we're going to be doing. Hello? Yes. Sometimes it seems to hang. Maybe that's where your slides disappeared. That brings me to where do we want to go? And I'm sort of recalling the process of the IETF as I've sort of understood it. We write some content, we discuss and identify gaps, stuff happens in the middle, and then you go to working group last call. I want to basically reverse this order in the discussion that we're hoping to have. When are we declaring this work complete enough to working group last call? Then I want to identify the gaps until we are at the above points, how we identify these gaps, and then basically any other comments that anyone wants to provide it's basically my plan for this presentation here. So when are we done? In my humble opinion, but I don't get to decide this anymore because this is now a working group document, we have a decent amount of exposition of basically establishing, yes, it is hard, and also some content that basically says this is how things break in a way that you don't have experience yet with from your old systems. We have I think a decent amount of discussion of some solutions and approaches, including quite a bit of caveats on that. An example that you might remember from my prior time at this mic is that something that seems to come to mind to a lot of people is that we have this, oh, what if I just base the signatures on time and just give out something every couple of minutes? There's a lot of things you need to get right to run that sort of systems, and we have sort of an exposition about that, and we have that for a bunch of approaches. And I think it's also important to realize that this isn't completely open space in some way. We're never going to be able to be fully exhaustive. So this is my first question. When are we going to call this? Yeah, that is, I think, where I would like to invite people to come to the mic, hopefully people who have read the draft.
So if you have any questions or feedback, please come to the mic online or in person.
And since we're not having anyone coming to the mic, I think maybe a better thing to do is for us to do this on the list, saying we think we're, like we need input or else we are just going to go to working group last call. So let me ask a sort of salacious question. How many people in the room care about the state management? Because remember, this wasn't like a hard thing. Okay, so we've got a reasonable number of hands. How many of you who care have been keeping up with the draft and reading it? A much smaller number of hands. Okay, so I think what we need is more people reading it, and one way to get that is a threat of working group last call. But another way is just to encourage folks. We've got one person in line. Rich?
Yeah, hi, Rich Saul, Akamai. Do we still have to say that with the, I don't know. Anyhow, I think the exposition about yes, it is hard and this is how things can break, I would suggest we de-emphasize that in favor of this is the way to do things, because people who are looking at this are going to want to know what to do, and they're not going to worry about saying it's hard and here's the things that could go wrong. Don't help them get it done. So yeah, I think, as I said at the start, reduce the amount of the first two and focus on the right way to do things. Almost make this a BCP if possible.
That could certainly be one way to approach this. I think that, to be fair, a lot of the first point is sort of interwoven in also the second discussion. It might be hard to find one way to do things because people need to solve slightly different problems. But I would very welcome having this discussion, very much welcome having this discussion on the list. Sophie.
I disagree with what Rich just said. I would do the opposite of saying, like, do you really need stateful hash-based signatures? They are very, very dangerous. Here are alternatives that you might like more, like SLH DSA or MLDSA, or even like UOV or Mayo or whatever. Like, state management is very difficult. And I think the more we push the average engineer to think about the fact that whether this is the right choice for them, the better, because I have seen too many people consider state management easy and then discover later that it was in fact not easy.
I also agree with that position very much. There is actually in the introduction already a bit of a call out to this particular point. You should probably be using something else, I think, is almost literally what we wrote there. But also that if you have strong feelings about that, if anyone else has strong feelings about that, also just another paragraph that's now under working group change control. So please comment.
Yeah, so I would like to comment what Sophie just said. My name is Stavros Kousidis from BSI in Germany. The point of the draft is not to say, don't use it, use something else. It's saying that if you are interested in that stuff, we would like to give you some advice to not screw up completely. Yeah, so, and I would very much like to keep the introductory sections really stating, be careful when you are going to use stateful hash-based signatures. And the BSI is very much interested in the draft and participates in writing that because we are going to use that in PKI.
Great, thank you.
Okay.
So I think what we need is many more eyes on it. I would say you as author could be the instigator of that. I mean, we as chairs can as well, but if you do that soon-ish, given that this is holiday season or whatever, then it is, so it is upon us to say, yes, that's enough. Are you comfortable with a month or two?
I mean, I'm also going on holiday still, but
Got it. Yeah.
but yeah, let's at least have a discussion afterwards on what exactly. But what you mentioned prior with the sort of threat of last call,
Right.
I do think that this could also be a valid approach to prod the right people.
Okay. So, please. Oh, sorry. Flo.
Sorry, yeah, just a clarifying question, which hopefully is helpful. So there's already an Etsy document about kind of management of stateful hash-based signatures from last year, and hopefully helpful of like what we're covering here. What's the gap that your draft is filling on top of that?
I'm sorry. Who has a government? Who has a
Etsy.
document?
Etsy. It's referenced in Tom's
Okay.
document.
To be honest, I'm not sure what the latest status of that thing is. I mean, this has also been kicking around for a year and a half now, I think. So we might need to resync with what was going on there. I also don't know if any of my co-authors or maybe Stavros has any idea what happened there. But yeah, we should probably check for overlap.
Thanks. Sorry, that wasn't meant to be a trick question. It just, I guess, for finding like when we're done, it would be useful at least to fill any gaps that have been left. Thanks, Tom.
I have another one of those kinds of gaps later in these slides, but that we'll get to that.
Okay. So go ahead, but we now know that there's probably insufficient people who are prepared to deal with questions on this. So, but do go ahead.
Yeah. Yeah. Okay. Yeah. So gaps. This is basically we have content that is currently in the table of contents like this. We have a bunch of operational considerations, things your system basically needs to support to be able to do state management securely. Things like you need to have like atomic updates, which is maybe hard, probably hard. And then we explore a whole bunch of different kinds of solutions to handling state management, and part of that is being able to store like parts of your state maybe offline or separate. And this also includes a little bit of discussion at the end where we go beyond what's technically allowed by SP 800 for NIST SP 800-208 for those that are not bound because they're not the US government. One gap is that NIST is also making changes to SP 800-208. They had basically, there's currently text in there that says you need to generate your key inside of an HSM. It can't ever leave that HSM. But that has led to a lot of people commenting like, yeah, but what if this machine that I bought now and needs to still work 20 years from now because I expect to be still signing things by then? What if it's no longer supported by the manufacturer? So they made some noises about and did some proposing of things and had discussions of a mechanism to maybe transfer state between HSMs or maybe be able to put part of that offline. But since the meeting at the beginning of the year that I also talked about last time, nothing really has happened. It seems that NIST is having basically staffing and budget shortage. I will not get political, especially as I'm not a US person who gets to vote in the US, but it does seem that waiting for that might take too long. So we might need to figure out a very careful approach to write something that's not going to be incompatible with what they're going to do and maybe support some of the things that they've said that they would like to do. But this is something that is going to probably require a little bit careful threading of the needle. Any feedback that anyone has on this issue because they've been privately chatting or they know more about what's been going on is very helpful. But I also think that we might need to, we'll see how things develop, of course, but I think there's a real situation where we might need to do something before NIST is done with this work. Or, I mean, we can't just keep kicking this ball forward forever.
By the way, we are now running out of time.
Okay, I will hurry up. Separately, NIST is sort of investigating these state lights variants of Sphinx Plus, where they have like fewer numbers of signatures than let you sign arbitrary amounts of messages, but still somewhat stateless. And I was thinking, should this fit in the scope of this draft? Something to discuss elsewhere. Yeah, well, this is the end. So yeah, this is where people get to ask any remaining things that they want to say.
Any last comments? And again, we are going to make this active on the list soon. I would say this would be, once you have figured out your vacation schedule and such like that, that this is something that we can complete, or we can decide to keep delaying for other reasons. But Jean-Pierre?
Jean-Pierre Fizet, Crypto4A. As to the 800-208 question, I think the document provides a lot of guidance to people who are interested in this. I understand people are saying, well, we should tell the potential adopter, be careful and all that stuff. But most of the people who are looking at LMS and HSS, they're coming to this conclusion because they're quite constrained. I mean, it's not because they're not aware of what's going on. Waiting for, and these people are aware of 800-208, right? So waiting for this to come out, I don't think is going to help the process. I think what you've got now is pretty good, and I think we should proceed forward.
I also think that there's a world in which we revisit this question once NIST has sort of figured out what they want to do, and write an addendum in a follow-up work. That could maybe be one way to solve this issue so that we can move forward with this version. But that's something we can definitely also discuss on the list. Thank you.
Thank you. Chris, on adapting constrained devices? Yes.
All right. Chris Katkowski, PQ Shield. So this is work about how do we adapt post-quantum cryptography into, and how do we deploy it into constrained devices. This has been presented already on in Bangkok. The draft has a different name. So we changed this a little bit and we kind of cleared the scope and updated the content. So now this now that's about not about HSMs, but about constrained devices in general. So to motivate this work a little bit, maybe so the goal of the draft really is to be a kind of bridge between post-quantum and those smaller systems, which are very often have much less RAM, much smaller disk storage, the flash storage, and they are not running like huge CPUs. So when you look, for example, when you look at MLDSA, the memory usage of the reference implementation for assigning is around 68 kilobytes. Then those small devices, they often max 16 kilobyte of RAM. So this reference implementation is already would not fit. And also, if you compare it to DSA needs only 7 kilo. So there is a huge change. So then you can optimize the MLDSA, but to use 11 or almost 12 or even less kilobytes. But then if you look at the other table, this very, very small MLDSA will be, the difference in speed will be very, very big. So those are kind of things that we want to describe in a drive. in a draft. And so the reason to do it right now is, well, from one hand, there are millions of IoT devices running and connecting to the network. On the other hand, the post-quantum deployment is already going on, and people are trying to, of course, to integrate this into protocols. And really, to have such draft, it's kind of really the goal is to make sure that we don't develop systems that are very hard to deploy on those very maybe edge case devices. So what we want to address in the draft is to, well, practical implementation guidance and kind of describe trade-offs between small, fast, and also describe like key management and so the draft focuses on like has a like algorithm selections. There are MLDSA for signing is one, but there are more are coming. Same for MLChem. We described the key generation and usage lifecycle. There is a part about firmware authentication and also power utilization, which is actually quite important for those small systems. So the difference between the previous version and this new updated version is, well, we renamed the draft so that the scope is a bit clearer. We described this pre-hashing interfaces for SLH DSA and ML DSA, the mu signing and pre-hash ML DSA stuff. We described the firmware signing, and then added some RAM usage guidance, compared some signing algorithms, and added some text about ephemeral key exchange. So in more details, there is a part about like the seed-based key derivation or secret key expansion. There is a part about impact of PQC authentication. So here, for example, the MLDSA again, it's like quite big, and then it may affect the TLS session when you have like a small device and you want to do want to sign the message in the key on the server hurl. Then there obviously this will affect the big size of the algorithm will affect the TLS session. So we want to like kind of describe those things and have like profiles for different use cases. And then we added the pre-hashing interface and how to reduce RAM usage by doing hash and then sign. The firmware signing is actually quite important for constrained devices. So we recommend to use LMS because it's LMS, XMSS, and SLH DSA. LMS is very fast for verification, but obviously there are other problems that Tom mentioned just during the presentation before. And yeah, there's also we described the how to use MLDSA for firmware signing and when to use it. So in the next step, draft is it's not in final stage yet. So you want to add discussion about side channel security, concentrate a bit more on the practical implementation issues, kind of describe design strategies for different designs of the algorithm or uses of the algorithm, performance trade-offs. And obviously there are things like FNDSA coming, and that's actually can be useful for small devices, especially when it comes to verification. And there are also those new schemes, and for example, Hawk looks actually quite interesting for constrained devices. Also, we want to still update a bit the document structure and clear some stuff. So yeah, this is really call for feedback. If you have if this is interesting, then please review. If you have a deployment, then it's even more interesting to know about it. And yeah, any other suggestions we are open to them.
Okay, Scott?
Scott Fleur, Cisco Systems. One thing that I've found with MLDSA, which is annoying, is the fact that it uses massive amounts of rejected sampling, which means that the average time is such and such, but it may take a significantly longer period of time in like 1 out of 100 or 1 out of with 1% or 0.1% probability. And that is obnoxious if you're worried about real time. And you may want to address that.
Yeah, this is a very good comment, actually. That's definitely something to do.
So I think, oh, Britta, sorry.
Yeah, actually, I just wanted to say that this is very valuable work, and I appreciate you looking into these trade-offs, especially within those constraints. All right, provide some feedback on the mailing list, but we'll be happy to review when you provide some more. So thank you.
Perfect. Thank you very much, and thank you for the review.
So I think since this does seem like a much longer term document than the previous one,
yeah.
Why don't you drive the discussion on the list? It doesn't sound like you need the chairs to pick out things.
Sure.
As you find sections you want, please do update the document every couple months, because it does sound like you're getting a little bit extra in this section, a little bit here. Keep that going. But I would say when you're saying like, oh, we want more here, say that on the list. Do the discussion driving yourself.
All right. Yeah. I'll
and I don't mean you only, any of the co-authors.
Oh, yeah.
Yeah.
Yeah. Personally, I'll be happy to do it. So.
Right. Okay. Cool. Very good. Thank you.
Thank you.
So Britta, you're up next, I think. Yep.
Sure, I can click. Okay, this is a very short update on the hybrid spectrums draft. It's been a while, so quick recap. What this draft is about is essentially spectrums of what hybrid signatures provide in terms of security, in terms of functionality. If you look at chems versus signatures, once you start to hybrid things, there's actually a lot more here be dragons in the signature side. Trade-offs that you look for in, as I said, security side, but also things like, do you need a software module out of one? How are you going to combine them and so forth? So that's a quick recap. It's all there in the draft. We had a working group last call. It's been going through AD review, and we are down to, I think, one discussed item that was responded to and just needs to be reviewed by that person who had questions. So not much to see here. But quick recap on what we did change throughout that review process. There's a lot more adding clarity, some discussion on artifacts. So when you're talking about hybrids, it's really nice to be able to go back and investigate whether or not the hybrid was actually followed. This differs on if you are doing something based on policy, like a configuration hybrid, where your system simply says, check both signatures, versus if you actually have it cryptographically bound or maybe embedded in a message where you can look back and say, it's not just in a policy somewhere, but there's actually an artifact in the signed message that said this was supposed to be hybrid signed. So some of the LAMPS work uses ideas out of that. So there's definitely different spectrums there, and this clarifies some of that relationship on what artifacts are and what they are used for versus the non-separability, which is a security guarantee and completely different. Although, like anything with security, they're related. There's more clarification on configuration. So in the original draft, this is described as policy, what policies you have on doing hybrid signatures or doing, whether you check one or if it's enforced cryptographically. And one of the reviews said, what about configuration? Well, that's what policy was described as. So we just clarified the terminology a little bit, generalizing for black box options and clarifying some on the security definitions. So pretty straightforward, but all very good reviews and feedback. And now we are at the end, essentially. So if we did ask for any feedback on the list, if anyone had comments on the latest changes, no one responded. So all seems good, and we're just waiting for that last discuss to clear.
So next up, we have a document that may or may not come to the working group. Lucas?
Yes, works.
15 minutes, right? Okay. So can you keep it within 15 minutes? Yes. Great.
So hello everyone, I'm Luca Prabel and I'm presenting today a new individual draft that was published earlier this month and that aims to summarize range of widely studied post-quantum algorithms. So this draft provides a high-level overview of several post-quantum algorithms, both schemes and signature schemes. And for each scheme, we provide core parameters, underlying security assumptions, and other relevant practical consideration in a format which is unified and easy to compare. And so the motivation behind these drafts comes from several real-world needs. So first, now today we have many different options for PQC algorithms, but the relevant information is scattered across research papers, benchmarking platforms, standardizations documents, or agency guidelines. So it makes it difficult for protocol designers or implementers to make informed choices. Another point is that different security agencies require, like ANSI or BSI, require consideration for non-list algorithms. So there is a need for some people to understand a broader set of schemes. So that's the second point. Another point is that it's challenging to compare the different trade-offs between different algorithms, as key sizes, security assumptions, or maturity level are not always presented in a unified and consistent way. And finally, I believe this document supports some goals from the PQUIP Charter, especially regarding assisting the migration of protocols. So we envision this document as being useful to a broad range of stakeholders. So from protocol designers and standard bodies who need to select appropriate primitives to update protocols, but also implementers and developers of crypto libraries, or finally policymaker and regulatory bodies that need a high-level overview to inform policy decisions. So this draft, as I said, is high-level descriptions of post-quantum schemes and signatures. And for each scheme in this document, we provide key characteristics like parameter sizes, claim security level, but also the underlying security assumptions or security model, and also the standardization status of the algorithm. Also, the presentation format was designed for easy side-by-side comparison and to help the readers navigate different trade-offs. So it's not a deep technical dive, but it's more a comparative summary to help people being informed about the distinguishing features of different algorithms. And just a few words about what this draft is not about. So it's not a recommendation list. We are not endorsing specific algorithms or ranking algorithms. We try to write a neutral and descriptive draft. We don't provide any runtime comparison, as I think it would be more appropriate in other works. And even though we mentioned some standard security assumptions or security models for several schemes, we don't provide any security proofs or formal reductions. And so I think the main question behind this draft is about how we select the algorithms which are described. So we decided for this version of the document to start with the NIST and ISO standardized algorithms, but in the future we also aim to include schemes based on several criteria. So whether they are recommended by some recognized security agencies, whether they have been widely studied in academia, and whether they have potential for real-world deployments. And so going forward, we welcome any feedback from the working group on how, on which algorithm to add to the current list and how to improve the criteria so that they are more transparent and more consistent. And so looking ahead, we would love to receive some feedback on a few points. So as I said, are the current criteria satisfactory, or could we refine them? Should we extend also the scope of the document by, for example, including additional information about the schemes? And finally, is there a better way to present the results in the document? So yeah, thank you for listening. And if you have any question or suggestion, I would be happy to take them.
So we have a little bit of time for Q&A now, but since this is a new document, much more of the discussion should be on the mailing list. Chi-Tsung, you are in the queue. We're not hearing you. Okay, so we're going to skip over you. Britta, you put yourself in the queue, and we can come back to Chi-Tsung if you can't. Okay.
So just one minor thing, and you had this on, I think, your first slide of the deck. It's not in the draft, so hence why I say it's pretty minor. Right. So in your functionality descriptions here, a KEM is not a key exchange. It is a building block for a key exchange, but it's not a key exchange, it's not a protocol. And I know that's a point that often gets confusing, especially when you get to end implementers and developers. So it might be worth clarifying in the draft.
Okay, thank you.
Thanks. So, Tom?
Sommichers, I think that this is something that a lot of people are looking for. So in that sense, I think this is good work. It's also something that's slightly obsolete, part of the things that I do as my day job. So that's a good job. But no, I think the tricky thing here is scope. And there's a lot of things that are still not stabilized yet. So European Union Commission guidance has just put out a draft version and I think the draft technically only says that they're going to put out a draft next year that has the actual draft advice. Mm-hmm. And there's things in many other places that are happening. The Korean post-quantum cryptography standards come to mind. Which I guess are technically not standards yet, but just the output of a competition to do Korean post-quantum cryptography, and they might get turned into standards. So though we have a bunch of algorithms that are sort of, especially in the sort of left-hand column, the recommended column on this slide, that are sort of stable and documented and probably going to end up everywhere, there's also a lot that is still on the other side. That's where are we going with this, and where do you want to cut? Where do you want to call it? Like, we're gonna not add any more algorithms after this line. And I think that's probably something that I don't expect you to have an answer to this, but if we want to take on this work, I think that is probably the most important question. What is going to be the scope, and where are we ending the scope?
Yes.
So I would say instead of scope, it's the length of the list that we're talking? I mean, the scope is already broad this way, but then how many of the non-NIST algorithms would we be adding?
That's could be another way to phrase it. Yeah.
Okay. Right.
Another,
and that can be discussed on the list.
yeah, another slightly minor point is how much.
I'm seeing a couple more people in the queue.
Sorry.
We're going to cut this off so that we've got the last one. So yeah,
that's fine. Thanks.
Thank you, Tom.
Jean-Michel.
Yes, Jean-Michel Combe, Orange. We are doing more or less the same thing inside my company, but with a larger scope, including symmetric cryptography and hash functions too. And in fact, this is clearly more harder regarding symmetric cryptography and hash function, because currently there is no clear consensus from all the cyber agencies about this topic, which is not the case for asymmetric cryptography. And by the way, currently inside my company, we recommend not to use LMS and XMSS algorithms, because there is no currently guidelines to use them.
Thank you. Gauss?
Bosman, Cloudflare. I think there's a need for having this easily searched, but there's two groups, right? There's the stuff that's ready to go now, and there I think the guidance is more protocol specific, and there's already guidance with TLS as a recommended column, etc. And then there's looking ahead, right? What is changing? What will be new? What will regulators think? And that changes year over year, and I've seen this. I've been tracking it for a few years. If we finish this now, next year we'll have to update it. Is an RFC the best place to keep track of that, and not just a nice website of filters and sorting?
Scott?
Scott Fleur, Cisco Systems. I was going to ask exactly the same question. What is the goal of this? Is it an RFC or is this a living document? Because there are things we know are coming down the pike. Chinese are going to come up with something. NIST has their on-ramp competition. It's going to take a couple of years, but something will pop out. What's the goal? Because I don't see how we can say at this time, this is what this is going to be, and there will never be anything in the future.
Well, yes, I think there will be at least a period where this document will need to be updated regularly. So in the end, in, I don't know, a few years, maybe it could become an RFC, or maybe the better way would be to just have a living document. Mm-hmm. Maybe it can be discussed on the mailing list, but I'm open to both options.
Thank you. Yeah, so clearly mailing list discussion is needed on this. Lots of people, including in the chat, have been talking about scope, again, horizontal and vertical scope. So last discussion is going to be Mike, who is going to tell us about the great private key war of 25. Mike, are you online? Yes.
Hello. Test?
Yes.
I was sharing Acme up until 30 seconds ago in a separate window, so I'm coming up a little bit.
Right, that's why I was asking. Yes.
Doing that thing where I was watching my name to come up. Okay, hello. All right. So this is a follow-up to my presentation at the last PQUIP in Bangkok. In keeping with my tradition of quirky titles, Much Ado About Encodings, a sequel to the critically acclaimed Great Private Key War of 25. So this is basically to inform the broader IETF community that LAMPS has gone and done it again. LAMPS has gone and done another sent a thread i.e. 100+ reply chain about PQ key formats. And I'm guessing very few people have read all of this. So my goal here is to just inform the broader community about what this discussion was about. And I, of course, have a personal opinion. I will try and keep my personal opinion out of this presentation. Also, this talk is essentially advertising because this will come up tomorrow at LAMPS. So LAMPS just happened in the previous hour, and now we have PQUIP, and then LAMPS 2 is tomorrow. We specifically asked for composites to go on the second day so that I could do this presentation first. So if you have an opinion about anything I'm going to raise in this slide deck, come to LAMPS tomorrow. Composites is first. All right. So first, I'm going to go back into a bit of a history lesson. If we're going to talk about key encodings for post-quantum stuff, let's first do a quick recap of key encodings for stuff we have already. So ranking things sort of in roughly older to newer order, which is a bit problematic to put specific dates on things, but roughly older to newer. First there was RSA, and then there was elliptic curve, and then there was curve 20519, and now there's post-quantum. And let's see what we've done historically and where we've made mistakes and what mistakes we don't want to repeat with post-quantum. So in the beginning, there was RSA, and there was a single way to encode it, and that single way to encode it was ASN1. And basically, in the 90s, if you had an RSA public key, it was encoded as an ASN1 sequence, regardless of what kind of protocol you were carrying it over. That there is an exception here. Jose, JWT, defines its own JSON-based encoding where N and E are carried separately, but by and large, everything just uses the blob, binary ASN1 blob. And the question I ask on this slide is why, and I wasn't part of the JWT working group when this decision was made, but it's not totally clear to me why they need to split N and E out separately. Maybe there's some horrible hatred for having to parse an ASN1 parser, carry an ASN1 parser. Maybe you want to be able to carry N and E down to your crypto library without having to parse ASN1. But I think it's, you know, why would you need your application layer to be able to read N and E separately? Unclear. This allows you to do it. Why do you need to do that? Unclear. So then after RSA, there was elliptic curve. And there was this great, oh no, now we need to handle two things. There's more than one type of public key in the world. And how did we decide to encode that? Well, there's two standardized encodings. There's the EC point, which is generally the IETF, certainly the X509 encoding is all an ASN1 EC point. And then there's the X962 format, which is just raw bytes. And so you see here from RFC 3279, an EC point is an octet string, but it's still not the raw data. It's got some wrappers in it. You've got this lead byte that tells you whether it's compressed or uncompressed. And then, which means already there's multiple encodings. This EC point can carry multiple different types of data inside of it. And then we go over to the signature value. So from public keys over to the signature value, and an EC signature value in PKIX, also from 3279, is a pair of integers encoded into a sequence. And this, I think, and I'm going to put Russ Housley on the spot, I think we all, including Russ, agree that this was a mistake. We should have just picked a fixed length encoding for the signature value. And the problem here is that the encoding rules for an ASN1 integer, when you take an integer and encode it to binary using the DARE encoding, you drop leading zeros, which means these R and S values can fluctuate by 1 or 2 bytes, depending on whether they happen to have a leading zero in them, which makes this particular encoding extremely annoying to work with in practice. Right. But that's how it is, and that's the encoding we're living with. Okay, newer thing. Oh, I'm sorry. Yeah, the other encoding is X962. And here it is just bytes. They provide a concrete integer to octet string, which always produces the same length of output. In a lot of respects, I think this is what we wanted. This is what we should have done in the first place. Unfortunately, this is not how IETF standards work, so we have to carry forward EC point, but I think we generally all agree, just give me the bytes. Okay. Slightly newer stuff. The Edwards curve stuff avoided this whole problem because everything is just a U coordinate. public keys, ciphertexts, signature values are encoded concretely also. I don't have them on the slide, but it's all fixed length. Beautiful. Like this is an X25509 public key. That's it. There is no alternate way to encode this. It is just a 32-byte value. You couldn't wrap this in a sequence if you wanted to, which makes this really nice to work with because no matter what protocol it's in, PQUIP, TLS, JWT, a public key is a public key is a public key. Phenomenal. Okay, so what have we done with post-quantum? So with post-quantum, it's not quite the same as X20519. There is structure here. An MLDSA public key has structure. It's a 32-byte random seed row followed by a compressed polynomial vector. But NIST has done us a really nice thing, and they've told us exactly how to turn that into a byte string. So you cannot, there's no room here for multiple encodings of this row and T vector because NIST gives us the encoding, which means for all intents and purposes, an MLDSA or MLCAM public key is a binary blob, single unique way to do that. And then all the protocols that have decided to carry this have just carried that forward. So in X509, we say that an MLDSA public key is a bit string. Do not look inside it. It is just bits. JWT has done the same. They've registered this new field called pub, which is a deviation from previous ways that JWT carried public keys. They've just said, you know what, bytes. I think this is personally good. You will not see this. You will never, you should never, if you try to do this, shame on you. You will never see an application or protocol layer data structure that tries to break this out into pieces. Don't do it. There's no reason to do it. And the question I ask here is if you did think you wanted to define your own data structure to carry the pieces of an MLDSA key, why? Why is there any reason for the protocol layer to have to know how to parse this thing apart? You know, modern crypto design, we have the application layer, the protocol layer, and then the crypto library. And we're making a sort of implicit decision here that the internal encoding of the crypto objects is a crypto library problem, not a protocol problem. You should not be able to parse this at the protocol layer. You have no reason to. You're just going to screw it up, treat it as bytes, hand it down, right? That's the philosophy we're using for modern crypto algorithm design. Okay. And that's basically what I've said here. So why do we prefer one encoding to rule them all? The protocol layer really has no business. It's the crypto layer that has to parse it. We don't want these key encodings to be different depending on what the carrier protocol is. You don't want your crypto library to have to know about X509 encodings of MLDSA versus JWT encodings versus C. You know, no, this should just be bytes, and you should just pass it down, and it should just be MLDSA as MLDSA. So far, I think I'm saying nothing controversial, but that's coming. Where this gets complicated is hybrids. So I'm using X2 or X-Wing as an example here. So now we have multiple public keys and multiple ciphertexts we need to encode. And I'm putting up the Keeping Up with the Chems paper, which says that you actually need to bind the public key of the X25519 component into the KDF, or else things go squirrely. We need public key binding. So now we're getting into a situation where it actually matters which encoding I picked for the X25509 public key, because if I took the same public key and I decided to encode that X25509 public key in a different way, suddenly I arrive at a different shared secret. So now starting with constructions like this, choice of encoding of public key actually breaks interoperability. There are also discussions about doing public key bindings within signatures. Should you put the public key into the context value so that the public key is bound to the signature? And then again, we're introducing this problem where the choice of encoding breaks interoperability. So this is another reason why we prefer one encoding to rule them all, because then you cannot get into problems if you start binding public keys into signatures or ciphertexts. Yeah. So this brings me to the hook. Why am I giving this presentation? Because hybrids. So back to this Senta thread. So what went on in this 120 odd email thread? The core debate here basically boils down to, is a hybrid one algorithm, which should be treated as an opaque object at the protocol layer, or is a hybrid two algorithms that should be easily decomposable? And maybe some participants in this thread would not quite agree with me summarizing the thread all the way down to that level of abstraction, but to me, that's the core issue here. Should the hybrid be protocol layer decomposable or not? And so we get into discussions, and especially in PQUIP's land, we get into discussions where the two halves of the hybrid might come from different crypto modules. Maybe you already have a smart card that does RSA, and you're pairing it with a piece of software that does MLDSA, and now your two keys live in completely different places. So now something definitely needs to pull that apart and funnel one to one module and the other to the other module. Does that require an encoding, a protocol layer encoding that allows you to split them apart, or is that still crypto layer? Is sort of the core discussion here. So we've had a few different ways proposed to do this, right? And what's at the top is the current definition in the LAMPS composite draft. Is your public key is just you take the bytes of the two things and you smack them together as bytes. That's it, raw concatenated bytes. We've had ASN1 sequence wrapping. One version of the draft we carried a sequence of subject public key infos, which was like extremely X509 specific way to carry these things. You stick an OID and then the raw bits, and you put a sequence of OID raw bits, OID raw bits. In the history of the LAMPS composite drafts, we have had all of these versions complete with test data in there. So we've explored all of these. Number one is what's currently in the draft and what I currently personally believe is correct. But LAMPS is sort of revisiting whether this was the right decision. So the arguments in favor of one opaque encoding is that the security and negotiability properties of a composite assume that it will be treated as one algorithm by the application protocol layer and only decompose with the crypto layer. Basically, there is complexity here. Let's hide it. Let's make the crypto layer solely responsible for that compatibility to reduce the amount of code that has to touch this thing and therefore could get it wrong. And so if that's true, then there's no reason to make it easily decomposable at the protocol layer. In fact, it could lead to bugs if you do make it decomposable at the protocol layer. And then also this argument about PK bind or CT bind, that the more possible ways you have to encode the public key in ciphertext leads to more possible compatibility problems at the binding. So if a composite key is always a composite key and there's only one way to do it, then you can't possibly arrive at the wrong binding value. The arguments on the other side of this debate, there's multiple, so it's hard to put a single argument here, but one of them comes down to future proofing. The construction we have now is tailored to MLDSA and MLChem. And if in the future we come up with things that have variable length public keys or variable length signatures, the current encoding won't handle that properly. We've had the argument that protocol layer decomposability allows the protocol to enforce policy on the components. So for example, if you want to enforce only certain curves are allowed, or RSA keys have to have certain structures, or you want to actually check the key length, like go and explicitly check the number of bits of the RSA public key. And if you want to do that at the application or protocol layer, then you do need to be able to parse these things apart. So that's one argument that was presented. The last argument is that this fits more cleanly into existing crypto library architectures. So there's not all crypto libraries, but there are some crypto libraries, OpenSSL being an example, which are fundamentally X509 libraries. And in that library, a subject public key info is the correct way to handle a public key. So in that context, if you need to take a composite public key, split it into pieces, and then hand it to OpenSSL to actually do the RSA half, you need to reinflate the X509 object around it, which means you need some horrible lookup table. And so the arguments are that data should be carried on the wire instead of requiring the implementation to reinflate the X509 public key wrapper. So my opinionated answer as an author of one of the documents, yes, please.
Just giving you a 10-minute warning.
Absolutely, perfect. So my opinionated answer is these are all application problems. That defining a single opaque protocol agnostic encoding, the benefits of this outweigh the trials and tribulations that they will induce. The problems with, if you have to build a lookup table to reinflate, okay, that's still a lesser evil than having multiple encodings floating around. If you have to deal with multiple crypto libraries and split them out and put them back together, that's still a lesser evil than the problem that multiple encodings present. And that really a composite from the protocol layer should be an algorithm. You shouldn't know or care at the protocol layer. This is my personal opinion here. And this is the opinion of the LAMPS composite authors. And this is what we're going to try and push through to working group adoption tomorrow at LAMPS. So if you disagree strongly with this opinion, come to LAMPS tomorrow. We please very much do want to hear from you. And I'll just point out, in addition to me using LAMPS as an example, there's a draft for composite MLDSA in Jose, which takes the composite LAMP stuff and literally wraps it for JWT, and they take our encoding directly. No rewrapping of the encoding. It is the literal bytes encoding identical to the composites LAMP draft. Similarly, there's an MLDSA in TLS draft, which also takes our public keys and signature values verbatim and does not re-encode them. So to me, the fact that other protocol working groups are taking our encodings verbatim, to me, that I'm taking that as a confirmation signal that we're doing the right thing. Because we are not forcing ourselves into a situation where different protocols encode things differently. To me, this means we're doing it right, but I'm open to other opinions on this matter. What about private keys? So far I've talked about public keys and ciphertexts and signatures, but the other aspect of this CENTA thread is, should the private key encoding be coupled to the public key encoding? Or is it okay to have protocol-specific private keys? So if we allow the public keys and ciphertext to be protocol agnostic, can we still talk about protocol-specific private key formats independently? So this is a separate discussion. And in particular, last time, Great Private Key War of 25, I presented this choice thing that we ended up, choice seed expanded both. So now the question is, should a composite private key be allowed to carry this choice object? Currently, we do not. Currently, we say that the MLDSA or MLChem half must be a seed, is assumed to be a seed. If we did, and that's nice because the first object is fixed length, it's always going to be 32 or 64, which makes the decoder very simple. But if we say that the private key of the MLDSA MLChem half can be this choice object, well, one, now this is a LAMP specific encoding, and two, it's a variable length encoding, so we need to now put a length tag of some type in there. So this is a separate debate from the others, is should the private key format be protocol specific? And yeah, this comes back to the seeds versus expandeds versus hardware has shipped that can't do seeds type debate. I see Scott in the queue, but I will just do my last slide and then yield the queue. So in summary, since Bangkok, LAMPS has had another CENTA thread about PQ keys and signature encodings. This time, it's no longer about the seed versus expanded. We've, I think, dealt with that mostly. This time, it's specific to composites, and it really boils down to whether a hybrid should be considered an atomic algorithm and just have a single unique raw bytes encoding, or whether the hybrid should be protocol layer decomposable. I think we have rough consensus, a very tumultuous form of rough consensus to use raw bytes, but this is going to play out tomorrow at LAMPS. So if you have an opinion, please come to LAMPS. And I'll point out that the debate for public keys and ciphertexts is happening independently from the debates for private keys. And that's it. I yield to the queue.
Okay, Scott Fleur, Cisco Systems. It occurs to me that talking about private key protocols being protocol specific sounds wrong, because protocols should not be dealing with private keys. That should be something done in the back end if you have to migrate them or whatever. Protocols themselves should not actually have to touch them. So having a single format to do this back in of the room transfer sounds like the right decision. End of comment.
I'm guessing if I dip into Zulip, I'll find much discussion. Oh yes, 79 new messages since I started talking.
Okay. Mike, were you able to hear the comments or not?
I heard the comment from Scott.
Yeah, okay, good. I think and it's good that there's no one in the mic queue right now, because I think any comments on this is a good idea, is Mike's opinion a good one or not, should be tomorrow, not today. That is, we don't need to do it twice. I hope this was useful to people to be a learning. I'm seeing some nodding heads, good. Because not everyone follows LAMPS, and yet this will touch on things that they're doing and such like that. Richard.
Yeah, just to raise a parallel thing here, there's also been work on hybrid chems in CFRG context with, I've been helping out, and Deirdre and Buzz and Britta Hill and a few other folks. We independently arrived at the same conclusion that Mike just espoused, that opaque is the right answer. We'll be discussing that in CFRG later this week. So if you're interested in this topic, that might also be of interest.
Thank you. Good. I think that is it then. For what has been queued up, we've got Tom's draft that will be more active on the mailing list. We are waiting to hear from the ISG review of the one draft that we still have to discuss on. And then we will have more discussion on the list about adopting and such like that. So thank you very much for your attention. Take care.
That was kind of I think it's all wrong. Yeah. And now they know that explained all why. Well, he guessed right. Yeah, what do you guys want to do? Want to know? Oh, is that now? At the time, there wasn't a oh, you're not. I went to you guys. You kind of did. Well, because I was confused on what the hell? Yes, that was very good. Nice history lesson. Yeah, no, that was very, that's right. Amelia's right here. So